Hello my dear students, welcome to Siddhi chemistry classes. In today's lesson we are going to see structure of atom. In that structure of atom specially we are going to see radius of an orbit and energy of an orbit. So this is one of the very important area from where they are asking questions in JEE as well as NEET. Without any delay, get start into the topic. So first I would like to explain some conversions, okay, so which are required for to understand in easy way radius and energy. So first suppose if you have note you can take here, it is very important. Suppose 1 angstrom is there. 1 angstrom is equal to how much? 10 power minus 10 meter. The standard conversion first you remember. 1 angstrom is equal to 10 power minus 10 meter. So how many centimeter will come? Okay, 1 meter na 10 power 2 centimeter. So what it comes? Okay, you will get 10 power minus 8 centimeter you will get. Now 1 picometer is equal to 1 picometer is equal to 10 power minus 12 meter. Then how many centimeter? Again same 1 meter is equal to 10 power 2 centimeter. Then you will get 10 power minus 10 centimeter you will get. Similarly 1 nanometer is equal to, we are 10 power minus 9. Nano now means what? 9. Okay, minus 9. Pico na minus 12. Angstrom na minus 10. Now this meter you convert into centimeter, how much you will get? 10 power minus 7 you will get centimeter you will get. Okay, so this and next this conversions, okay, every student must know. Why? Because these conversions are very important in structure of atom as well as in solid state in 12th standard. So first we will see, I am going to teach you this radius of atom as well as energy of radius. So I am going to discuss I am going to teach you as a differences, so you can remember it very easily. First I am going to teach you radius of stationary state. Radius of stationary state. Radius of stationary state. So this radius of stationary state formula Rn is equal to n square h square by 4 pi square mz e square is the formula. Okay, generally this is the formula. Once if you observe in this, except n square means the shell number, and z, except n square and z, remaining all are constants. Okay, in this one n means shell number or orbit number, and h means what? Planck constant 6.626 into 10 power minus 34 joule, and pi means 3.14, and m means mass of electron. What is the mass of electron, dear students? 9.1 into 10 power minus 31 kg. And next z means atomic number, and e means charge of electron, that is how much? 1.6 into 10 power minus 19 coulomb. Okay, once you observe in this, except shell number and except atomic number, remaining all are constants only. If you substitute all these, then you will get the formula is Rn is equal to, you will get 52.9 into n square by z. Picometer you will get. N square by z picometer. Okay, this is here. N means what? N means it is a shell number, and z means what? Atomic number. So from this one you can understand that radius is directly proportional to n square. If shell number increases na, radius increases. We know, right? First shell na near, second shell 2 square na 4. Okay, and what 3 square na 9. Okay, 9 into 52.9, like that. So as n value increases, the principal quantum number increases, radius what will happen increases. Here n means what? Shell number, nothing but what? It is a principal quantum number, right? Now this picometer I want to convert into angstrom. Okay, how to convert? You see here, why I said these conversions now, you can convert very easily. See here, 1 picometer is equal to how much? Okay, 1 picometer is equal to, okay, 1 picometer is equal to 10 power minus 12 meter, and by 1 angstrom is equal to how much? In meter only you have to take 10 power minus 10 meter. Okay, so 1 picometer by 1 angstrom is equal to how much you will get here? Here 10 power minus 10 na 10 power minus 10 cancel, you will be having 10 power minus 2. So 10 power minus 2 by 1 will be having. So what you will get here? Okay, 1 picometer is equal to, you will get 10 power minus 2 angstroms you will get. 10 power minus 2, just cross multiplication. Okay, 1 picometer is equal to 10 power minus 2 angstroms. Any type of conversion you can get it. So from this one we can write, if you want angstroms now, angstrom is equal to, okay, 1 by 10 power minus 2 picometer. Then angstrom is equal to what we can write? 1 angstrom is equal to, we can write 10 power 2 picometer you can write. Okay, 10 power 2 picometer you can write. Okay, so next here we want the conversion. Picometer you have to convert into 1 picometer, you have to convert into angstrom. So 10 power minus 2 angstrom. So you can substitute. So what we can write? Radius of an atom is equal to 52.9 into n square by z. Okay, 10 power minus 2. Okay, angstrom. So what you will get formula? Rn is equal to, you will get 0.529 into n square by z. Okay, angstroms you will get. It is in angstroms. Okay, here these two formulas are important. The first one is in picometer formula is important, and conversion you can leave it. Okay, the angstrom formula is important. Now you can convert into meters. Then Rn is equal to, you can write 0.529 into n square by z. Okay, into 10 power minus 10 meter you can write. The similarly Rn is equal to, you can write 0.529 into n square by z 10 power minus 8 centimeter you can write. Okay, this one. Now see here, dear students. Okay, these are the conversions. Okay, once we will observe here what is the common thing here. Okay, note we can write here. Note we can write the radius Rn. Radius is directly proportional to n square. Means if as shell number increases, radius increases. Correct? Let us say it is a one atom. In that atom it is the first shell, it is second shell, and it is third shell. So it is since it is the first shell, it is what? N is equal to 1. Second shell now n is equal to 2. Third shell now n is equal to 3. So if shell number increases now, what happened? The radius from the center of the nucleus to the valency shell, what is happening? Increasing. Okay, right, like this. So here n square we are doing, so it will be keep on increases. So next thing. Okay, next thing in textbooks and all we can see hydrogen atom radius. Note we can write for hydrogen atom, what we can write? For hydrogen atom. For hydrogen atom means, okay, here what I said here, n is equal to shell number. Okay, and z is equal to atomic number. So at atomic number I have to write 1. So what I will get? Rn is equal to, I will get 52.9 into n square picometer. Similarly Rn is equal to, I will get 0.529 into n square angstrom will get, and radius is equal to 0.529 into n square into 10 power minus 10 meter you will get. Meter, and radius is equal to 0.529 into n square into 10 power minus 8 centimeter you will get. Okay, this one. Okay, this is the radius. So let us there are the questions based on this formula Rn. Okay, there are the questions now in NEET and JEE books. Now we will see energy. Okay, so energy of stationary state we will see. Energy of stationary state. Energy of stationary state. Why I have told you, like we will compare and we'll study now. The formula for energy will be also same, but little bit difference. Okay, you have to make a reciprocal it. So 2, okay, instead of 4 it will come 2 pi square minus 2 pi square. Okay, minus 2 pi square. Okay, m will be for ze square we have to do again square. Then what you will get? Z square e power 4 by n square and h square. Okay, once you observe the difference what is there in the radius and what is there in the energy, what we have done, once again I am telling, okay, just we are reversing, okay, we are reciprocaling. So 4 pi square m z square is there, no? Okay, the 4 pi square will become 2 pi square m. Okay, for z square, no, for that one we are doing whole square. So z square e power 4 you will get by n square and h square. And once you can observe in this one also same thing, except z, okay, and except n. Okay, all are constants. See here, n means what here? Shell number, and z means atomic number. Except these two, except these all, okay, except these remaining all are constants. Remaining all are constants. Okay, if we substitute all the remaining things and all, what you will get here? Okay, you will get En is equal to, you will get minus 2.18 into 10 power minus 18. Okay, 10 power minus 18 z square by, okay, n square joule atom. Okay, and this one you have, this one I want to convert into ergs. So can you say ergs formula? 1 joule is equal to how many ergs ma? Okay, 1 joule is equal to 10 power 7 ergs. So that one substitute. Then En is equal to, will get minus 2.18 into 10 power, okay, minus 18 plus 7 now how much will come? Minus 11. Okay, z square by n square, okay, erg per atom. Okay, this formula also important, right? And next one we will see. Okay, next one. Okay, energy of an atom, energy of a radius, I am writing in electron volts, minus 13.6 into z square by n square. Okay, electron volt per atom we can write. Similarly, energy of an orbit is equal to, we can write minus 1312 z square by n square kilojoule per mole, we can write kilojoule per mole, 1312. Okay, and next, energy of a orbit is equal to minus 313.6 into z square by n square kilocalorie per mole, kilocalorie per mole we can write. Okay, these conversions are very, very important. These formulas are very, very important. Okay, so in this one mainly here you have to focus to remember En in joules. I think so most of the students they know 1 joule is equal to 10 power minus 7 x. So you can obviously you can remember the second formula. And next there are many questions. Okay, En is equal to minus 13.6 z square by n square ev by atom. So why this formula you have to remember? Means z square by n square, include this one, remember. So sometimes they are giving, okay, energy of second orbit of lithium they will give. Okay, lithium they will give. So lithium means what? Z you have to put 3 square, n square now how much? Second orbit means what? 2 square. Okay, n value you can take 2. Okay, so in books and all, in some materials and all, they given for hydrogen atom alone given this one. Okay, student, they will remember only this formula, and sometimes they will ask you for lithium second orbit. If they ask na radius, here they will put 2, they will put z, they will leave it. Why? Because they might not know these formulas. Okay, so always remember with n square by z. For radius na, you have to include n square by z. Okay, you have to remember radius of an orbit is equal 52.9 into n square by z picometer, like this. Similarly, energy also like that only. Energy En is equal to minus 2.18 into 10 power minus 11 z square by n square earth per atom. Okay, if joules na, En is equal to minus 2.18 into 10 power minus 18 z square by n square joule per atom, like this. Okay, now I am going to tell you one very important point. See, so now I am going to ask you one question. Why always energy is having minus charge? Okay, why it is having negative symbol? The reason is negative charge shows that electron bonded to the nucleus. Okay, the negative charge shows, not very important point, they may ask in statement type questions. So remember, negative charge shows, negative charge in energy of orbit shows, negative charge shows that electron bonded to nucleus, bonded to the nucleus, okay, that is the meaning. Suppose if you see greater the value of negative charge na, strongly the electron is bounded to the nucleus. Okay, if you observe greater the value of negative charge, negative energy we can say. Okay, negative energy, sorry, here not negative charge, okay, negative energy, okay, negative energy, okay, greater value of negative energy, okay, greater the value of negative energy, more tightly the electron is bounded to the nucleus. What is that? So the negative, whatever the negative value is there, negative energy is there, that represents what? The electron is bounded to the nucleus. Okay, suppose if you are having more negative value na, the electron is more tightly bounded towards the nucleus. That is the meaning. Okay, this one. So right, so for example I am going to tell you here, let us say one electron is there, okay, which is present in a first shell. Okay, which is present in first shell. For this one I am saying minus 1200 kilojoule per atom energy is there. Okay, and another electron is there in a, okay, second shell. Let us say for that we are having minus 680 kilojoule per atom is there. Which is strongly bounded here? Okay, the first one is strongly bounded. Okay, that is the meaning. Okay, this one. So this is. So we will see some problems based on okay, these formulas. Okay, you can see the first problem. If R1 is the radius of the first hydrogen atom, then the radii of second, third and fourth orbits in terms of, okay, R1R. So first you have to find out R1 is how much. R1 is equal to 52.9 into Rn is equal to 52.9 into n square by z. Okay, picometer you are having no formula, correct? So R1 is equal to 52.9. Here n value how much na? R1 means what? It is the first orbit. So 1 square, and it is belong to the hydrogen atom. So what? It is 1. So picometer. So you will get R1 value, you will get 52.9 picometer. You will get this one, R1. So now you have to find out R2. Okay, R2 is how much? R2 you will get 52.9 into n square not 2 square by 1. Okay, which means you will get 52.9 into 2 square now 4 you will get. So this is what R1 now in terms of R1 they are asking. So it is R1. So what you will get here 4R1 you will get now. The 52.9 I am writing as a R1. So what I will get 4R1 I will get. R2 is equal to what? 4R1. Now R3 is equal to how much will come? Okay, let me write this side. R3 is equal to I will get 52.9 into 3 square by 1 picometer. So this one you can write as a R1. Then what we can write? 9R1 we can write. Okay, 9R1. Now R4 is equal to what we can write? 52.9 into 4 square n square by z 1. So picometer. So what we can write here? 4 is 16. Okay, 16, and this one what we can write? 52.9 means here I told you. Okay, this side. Okay, so we can write it as R1. So what we can write here? Okay, so the answer is what? If R1 is the radius of the first of hydrogen atom, then the radii of second, third and fourth orbit in terms of R1 means you will get the answer is, okay, second orbit you got R1 4R1, next third orbit you got 9R1 and what 16R1. So what is the answer now? The answer is the second one is the answer. Okay, and next we will go for second question. The radius of hydrogen atom arrow in ground state. Okay, sorry, it's a ground state. In ground state is 0.53 angstroms. Okay, the nearby value given 0.529 now, so they given 0.53. Okay, round of value, not a problem. The radius of lithium plus 2 in a similar state is, okay, fine. So similar state means what? It is there in first state only. Okay, so we will see. Okay, so we are having Rn is equal, the formula is Rn is equal to 0.529. We have taken angstroms only. The reason is angstrom is there in answer. Okay, so angstroms. So here angstroms only you take n square by z square. Okay, angstroms. Sorry, no, not z square. Okay, n square by z angstroms. So what we can write here? R. Okay, R is equal to 0.529 into n square. Now how much? The radius of first orbit only. It is also first orbit. Ground state na, ground state represents what? It is a n is equal to 1. So first orbit. So by z value how much it is? 3. Okay, lithium na it is what? 3. So what you will get? Angstrom. So 3 ones are 0.3 ones are 3. So 2 remains. So 3 sevens are 21. Okay, so 1 remains. So 3 6 are 18. So you will get radius is equal to, you will get 0.176 angstroms you will get. So what is the answer here? The fourth one is the answer. Okay, fourth one is the answer, right? And next one we will see. Third question. The Bohr orbit radius for the hydrogen atom. Okay, 0.530 angstrom. The radius of first excited state. This will be very interesting question. So what they are asking, radius of first excited state. What is the meaning of first excited state? Suppose this is a nucleus and it is the first shell, n is equal to 1, and it is the second shell. So the n is equal to 1 na, it is the ground state. This one also they can give as a ground state. Okay, n is equal to 1 means they can mention as a ground state. Okay, when the electron gains energy now, it will go for what? Excited state. So n is equal to 2 means what we can write? It is the first excited state. We can write first excited state. Suppose if they ask second excited state means which one you have to take? Second excited state. N is equal to 3 you have to take. Okay, n is equal to 3 means that is what? Okay, second, okay, excited state you can take. Okay, like this. So, right now the radius. Okay, radius. So they are asking in angstrom only. They are asking. Okay, they are asking in angstrom only. So here Rn is equal to, we are having 0.529 into okay, into n square by z angstroms. So r of first excited state na it is the second orbit. Okay, you can see the ground state na n is equal to 1, first excited state na n is equal to, so n is equal to, so 0.529, so r2 only you have to write into 2 square by z. Z value is how much? 1. Why? Because it's a hydrogen atom. Okay. Right. So R2 is equal to, you will get 0.529 into 4 angstroms you will get. So R2 is equal to how much you will get? 52, 0.524 okay, 208. Okay. So you will get nearly value, you will get 2.12 angstrom you will get. Okay, this one is the answer. Okay, like this. And next one, right, now we are going to see energy associated with third energy shell. Okay, energy associated with third energy shell. So what is the formula here? Third energy shell of hydrogen atom, it is a hydrogen atom. Okay, so En is equal to, we can write minus 2.18 into 10 power minus 18, okay, into z square by n square, z square by n square joule per atom. So En is equal to, we can write minus 2.18 into 10 power minus 18 into z value how much nana? It is a hydrogen atom, so it is a 1 square by n square is how much? It is a third, so what? 3 square, 3 square, okay, joule per atom. So what we can write here? En is equal to, we can write minus 2.18 into 10 power minus 18 by, we can write 1 square na 1 multiply 1 only will be, so 9, okay, joule by atom. Okay, fine. This one if you simplify na, okay, you will get En is equal to, you will get nearly, you will get minus, okay, minus 2.42 into 10 power minus 19 you will get, okay, joule per atom. Here Sima, I want to explain some concepts from this one. So here energy of a orbit is directly proportional to z square ma. Okay, means, okay, energy increases, okay, what are negative energy? Negative energy increases, negative energy increases as atomic number increases, as atomic number increases. Why? Suppose, see, suppose let us take we are having it is a lithium atom. Okay, lithium atom, okay, lithium atom. So here I am talking about the first shell ma, n is equal to 1. Here let us imagine here one electron is there, one electron is there and it is a lithium atom. Okay, so we are having 1s2 2s1 electronic configuration, 3 electrons no. So I am talking about, okay, in 3s1 one electron, on that one how much energy it is operating, means how much negative charge is there. Okay, negative energy is there means what? It is more tightly bounded. So the same way in the second period, the lithium belongs to second period. The second period another element I am taking, that is fluorine I am taking, fluorine. So the fluorine also, fluorine having electronic configuration 1s2 2s2 2p5. So here also I am talking only the electron present in first shell. Okay, so which one is very tightly bonded? Now tell me, which is very tightly bonded? The very tightly bonded is fluorine atom first shell electron is tightly bonded. The reason is, in this one z square means z square means nothing but what? Number of protons will increase inside the nucleus. Here what will be here? 9 protons will be. 9 protons can hold the first electron, first shell electron more effectively, can bind the first shell electron more effectively. In this one lithium how many are there? In this one only 3 protons are there. The 3 protons comparatively in fluorine 9 protons will catch hold the first electron more effectively. Okay, more effectively. In lithium 3 protons cannot hold as much as fluorine protons are, okay, pulling the electron. Okay, so here what the first electron is what tightly bonded in lithium, loosely. Okay, in lithium first shell electron not tightly bonded as in fluorine atom first orbit electron tightly bonded, correct? Here it is more tightly bonded, first orbit electron is more tightly bonded, okay, in fluorine atom. In the same first orbit electron, okay, little bit loosely, means the reason is what here only 3 proton compared to these two. In fluorine only first orbit electron is tightly bonded than the lithium. Why? Because here atomic number is more, number of protons are more, so that's why fluorine can tightly hold the electron when compared to the lithium. Okay, this one. Now we will see in this question, En minus 313.6 by n square kilocalorie per mole if the value E is equal to minus 34.84 kilocalorie per mole, to which value does n belongs to, right? So the formula you can take En is equal, what is the formula we are having? En is equal, we are having minus 313.6 by n square. Why they given by n square? Is it different formula or same formula? Yeah, same formula only, but here since it is a hydrogen atom, okay, here they substituted 1. Okay, so 1 square, now what you will get here? En is equal to minus 313.6 by n square you will get kilocalorie per mole. So from this one what they given, the En value how much they got it since? Minus 34.84 they got it since. Okay, so minus 313.6 by n square is there. So in this one n square you have to find out. N square is equal to minus 313.6 by minus 34.84. So here n square you will get okay, nearly you will get a 9 value, you will get 9. Then what will happen? N is equal to what? 3 is the answer. Okay, here n is how much my here? 3. Okay, and next question, sixth one. Okay, the sixth one we'll see. The sixth one, in a hydrogen atom, if energy of an electron, the second excited state, the helium plus energy is, okay, in a hydrogen atom, if the energy of an electron in the second excited state, helium plus energy is, okay, electron, the question completely not came here. Okay, the question is, in a hydrogen atom, if the energy of an electron in ground state is minus x electron volt, then that in the second excited state helium plus energy is how much? Right. So they are giving in EV, no? So first we will see the hydrogen atom, the energy of electron in ground state, means the Z value is how much? Hydrogen atom means Z value is equal to 1, and ground state means N value is equal to 1. So what is the formula we are having? En is equal to minus 13.6 into, okay, Z square by N square, okay, Z square by N square, electron volts, correct? Okay, electron volts, okay, electron volts per atom, this formula. So here what we can write, En is equal to, we can write minus 13.6 into, okay, Z square, now 1 square, 1 hydrogen atom and it is the ground state, so EV per atom. So you will get energy of first orbit, how much you will get my here? E1 is equal to, you will get, okay, minus 13.6 electron volt per atom you will get. This one they are considering as what here? This one they are considering as a minus x. Okay, now second excited state of helium. So first excited state means what I told here, in previous problem also same thing you got it. Okay, here okay, it is the ground state. Ground state na n is equal to 1. From ground state to first excited state means n is equal to now this is what? First excited state, excited state, okay, and second excited state means how much? from ground state to first exit state now 2 and second exit state now what it is 3. N is equal to 3 is what that is second excited state. Second excited state. Correct? It is a second excited state. Second excited state. So you can substitute in that one. En is equal to, you will get minus 13.6 into z square. Now how much? Now it is a 2 square by n square means how much? 3 square. 3 square. Okay, means 9 you will get. Okay, 9 electron volt per atom. Okay. So this from this one what you will get? En is equal to, you will get minus 13.6 into 4 by 9 you will get electron volt per atom. So this one they given as minus x. So En is equal to what you will get? Minus x into what? 4 by 9 EV you will get. Okay, this is the answer. Okay, En is equal to minus x into 4 by 9 EV. So what is the answer here? Okay, it is a second one is the answer. Correct? The second one is the answer. Okay, right. Like this. And next one, see seventh one. In hydrogen atom, energy of first excited state is minus 3.4 electron volt. Then find out kinetic energy of same orbit of hydrogen atom. Right. So first excited state. Then find out kinetic energy of same hydrogen atom. Okay. Right. So here the hydrogen atom first excited state is minus 3.4 EV. Then find out kinetic energy. So remember always, okay, there is a one formula. There is one formula. Okay, just one statement. We can say it's a statement. Okay, total energy is equal to kinetic energy. But the kinetic energy always positive. Kinetic energy always what? Positive. So minus 3.4 EV. It is what? First excited state energy. In EV is minus 3.4. Then find out kinetic energy. The total energy how much they told? Minus 3.4 EV. Then the kinetic energy how much? That is also equal, same only. But the charge should be what? Positive. So what is the answer here now? The answer is what? First one. Okay, why like this? Okay, why always it is positive means kinetic energy will be having the formula half into mv square. Okay, kinetic energy will be always positive. Always it is positive. Why it is positive? The reason is mass always will be positive. Okay, the velocity may be positive or what? Negative. If positive means positive square, again positive only will be. So negative square also what will happen? Will get positive only. That's why kinetic energy, okay, never be negative. It is always what? Positive. This one you have to remember. Okay, and the problem also very important. In hydrogen atom, energy of a first excited state is okay, minus 3.4 means energy. Then the kinetic energy is how much? Plus 3.4. Okay, this one you have to remember. Okay, kinetic and potential energy in EV of an electron present in second Bohr orbit of hydrogen atom are respectively. Okay, first we will find out kinetic energy. How to find out kinetic energy? Just now I told kinetic energy nothing but what? Okay, total energy. Okay, nothing but the energy. Okay, means energy of orbit. Okay, we can say kinetic energy is equal to, we can say energy of orbit. So En is equal to what? We can write in electron volt minus 13.6 into z square by n square EV. So En is equal to, we can write okay, minus 13.6 into z means what? 1 square and 2 square. Okay, 2 square EV. So how much you will get? En is equal to, you will get minus 13.6 into, okay, into 1 by 4 EV you will get. Correct? So 4 ones are 4, 4 3 the 12.1 will be remains. So 4 the okay 16. So energy of a second orbit you will get minus 3.4 EV you will get. This is energy of second orbit. Okay, this is energy of second orbit is what? Minus 3.4 eV. Now you want to find out kinetic energy. So kinetic energy means how much? Kinetic energy nothing but what? Energy of orbit only, but you will be having positive 3.4 eV. 3.4 eV. Okay, now what you have to do now? Okay, you have to find out okay, potential energy you have to find out. How to find out potential energy? The total energy is equal to potential energy plus, okay, kinetic energy we can write. Okay, from this one potential energy is equal to, we can write total energy minus kinetic energy we can write. So potential energy is equal to total energy, how much you got? Minus 3 point, total energy you got minus 3.4 minus of kinetic energy, how much you got? 0.4 eV, 3.4. So you will get potential energy is equal to, you will get minus 3.4 minus 3.4 you will get. Okay, so potential energy is equal to, you will get okay, you will get minus 6.8 eV you will get. So the kinetic energy, so the what is the answer here? Kinetic energy is equal to, you got kinetic energy is equal to, you got plus 3.4 eV, and potential energy is equal to, you got minus 6.8 eV. So the answer is, C is the answer. Answer is the C is the answer. Okay, this one. Right. So here from this one we can write some conditions we can write. Okay, we can write some concept points we can write. That is, first one we can write kinetic energy is equal to half into minus negative of potential energy. Correct? Negative of potential energy we can write. Correct? Okay, negative of potential energy. You can see kinetic energy is what? 3.4. Potential energy is what? Minus 6.8. Minus 6.8 by 2 only, 3.4 no. So since kinetic energy will be always positive, you are taking what? Always positive only you are taking. Okay, actually I have to get minus 3.4. Kinetic energy never be in minus, that's why. So this is one formula you can write. And next one we can write potential energy is equal to what we can write? Potential energy is equal to, you can write 2 into, okay, 2 into kinetic energy we can write 2 into negative of kinetic energy. Negative of kinetic energy you can write. Got it? Okay, suppose total energy means okay, so here we can write total energy is equal to you can write negative of kinetic energy you can write. Total energy is equal to what? You can write negative of kinetic energy you can write. Okay, why? Because total energy will be always in negative, kinetic energy always will be in a positive. And total energy is equal to what we can write? Total energy is equal to, also you can write half into, okay, potential energy we can write. Potential energy. So potential energy, total energy, why we are here potential energy, why we are not mentioning negative means it always will be in a negative only. Okay, that's it. This one. So from this one you have to understand one thing. Note that, okay, potential energy and total energy of orbit, total energy of orbit and potential energy of orbit always negative, and kinetic energy of orbit, okay, sorry, not orbit, no. Okay, so here potential energy Okay, potential energy of an electron and total energy of an electron. Total energy. Okay, total energy of an electron always negative. Always negative. Okay, it is first thing. And second thing, kinetic energy of an electron always positive. Always positive. Why positive? Because of kinetic energy formula, what you will get? 1 by 2 mv square. So m mass of electron will be never be negative. Volume, velocity also never be negative. If it is negative now, what will happen? Negative into negative, you will get positive. So that's why kinetic energy will be never be negative. It is always positive. Okay, these are the very important concepts from structure of atom. Okay, radius of orbit and energy of orbit we have studied. Okay, suppose if you like the video, you can share with your friends. Okay, and you can subscribe my channel and leave a comment the topics, okay, which you want as a video. Okay, thank you dear students.